energy conservation applied beautifully to fluid flow. When a fluid flows, it has kinetic energy because it's moving, potential energy due to its height in gravity, and pressure energy stored in the fluid from surrounding particles pushing. Bernoulli's principle states that in steady, incompressible, non-viscous flow, the total energy per unit volume remains constant. Consider a fluid moving from point 1 to point 2 in a streamline. Work done by pressure at point 1 is given by W1 equals P1A1 dx1. Work done against pressure at point 2 is W2 equals minus P2A2 dx2. Net work done equals the change in kinetic energy plus the change in potential energy. After dividing by volume, rearranging, and applying steady flow, we arrive at P plus 1/2 rho V squared plus rho GH equals constant. This is Bernoulli's equation. The three terms represent pressure energy, kinetic energy per unit volume, and potential energy per unit volume. If one increases, another must decrease. Higher velocity leads to lower pressure. This is why a fast stream of air over an airplane wing creates lift. A shower curtain gets pulled inward, atomizers spray liquid, roofs blow off during storms, and narrow pipes have lower pressure at the tight section. The standard form for G problems is P1 plus 1/2 rho V1 squared plus rho GH1 equals P2 plus 1/2 rho V2 squared plus rho GH2. Using a 1V1 equals a 2V2, we solve all Venturimeter, carburetor, water jet, and airplane wing questions. This combination is one of the most tested concepts in JEE Main and Advanced. A constriction in a pipe causes velocity to increase, which leads to pressure decreasing. Pressure difference is delta P equals P1 minus P2. Velocity difference can be derived from Bernoulli and continuity. JEE frequently asks to find discharge, velocity at the throat, or pressure difference. When a fluid exits a small hole in a tank, the velocity is given by V equals the square root of 2gh. This comes directly from Bernoulli, considering pressure at the top equals pressure at the hole. It's used in water tank discharge, fountain problems, and jet speed problems. Air travels faster above the wing, causing pressure to drop, which generates upward lift. Conceptual questions in advanced often use P below is greater than P above. Fast air reduces pressure, causing liquid to be pushed up in an atomizer. Bernoulli's equation is valid only if the flow is steady. The fluid is incompressible and non-viscous. No additional energy is added, and the flow is along a streamline. Most trick questions test these conditions. For G tricks, if the radius halves, velocity 2 equals 4 times velocity 1. The pressure difference shortcut is delta P approximately equals 1/2 rho times V2 squared minus V1 squared. And for Torricelli, V equals 4.43 times the square root of H if G equals 9.8.